All right, so here we have a calculus problem. We're going to be calculating, well, sketching a graph. We want to sketch a graph of a function, piecewise function, and then figure out where the limits exist. So just kind of getting introduced to this limit idea. And so a limit is when we have the graph of a function, what is that function doing as we approach a certain value of x? So if x is approaching 3, what is the graph doing as we come up to that? Now, the limit is not worried about the value of the function at the point 3 in that case. It's only worried about what happens as we approach that value of x. So first we need to sketch this graph, and so this should be something you can do from algebra. With piecewise function, of course, you're looking at different functions based on the values of x. And so it might be helpful. So we're split at -1 and 1. And so it might be helpful just to kind of keep things organized. We kind of put a dotted line through the -1. We put a dotted line through 1, and that way we know where we are. Um, Next step would be to figure out the value of the function as we're approaching this point, -1. So in this case, -1 is defined in this middle part. -1 is not defined for this lower part or the first part. But we do kind of need to figure out what's happening as we get up to -1. So if we plug in -1, so let's say as x approaches -1 from the left, and you might have seen this notation talking about limits, f of -1, this is basically finding a limit. But we'll pretend like we're just going to plug this in because that's really what we would do. And so 2 minus -1 is going to be 3. So as we approach -1 from the left, we're going to come up to 3. Now, of course, this has a slope of -1. So we're going to be right there. Of course, we'll have an open circle because we're not including the -1. And then it's going to come down with a slope of -1, something like that. So that's the first part there. Then we have f of x equals x whenever x is between -1 and 1. So if we do this exercise again as x approaches -1 from the right, so now we kind of need to think about coming in from this direction towards -1 there. So -1 and 1. And if I guess we want to be more precise with this, we're really finding the limit as x approaches -1 from the right. And so that would be just the function would be x at that point. So this just comes to -1. So continuous function, you just plug in the value. So -1, we're going to be right there. And of course, that's closed because we are including -1 in this interval here. And then as x approaches +1, so now we're going to go to this side, +1 from the left. So the limit as x approaches 1 from the left. And again, we're using x because we're coming that direction. We're coming this direction. So that's just going to be 1. So we got a 1, and this will be an open circle because, again, we're not including 1 in this interval. And so we can go ahead and connect those. Of course, we go through the origin like that. And then last we have, as x is approaching 1 from the right, now we're going to use this function on the bottom. And so let's see what happens with that. So as x approaches 1 from the right, we'll have limit as x approaches 1 from the right, x minus 1 squared. And so plug in 1, and we just get 0. So that will be right there. And of course, that'll be a closed circle because we are including -1 there, or +1. So now, graph of a quadratic, obviously, you should probably know it looks like that or like that, depending on the leading coefficient. Or also you could, so if this is y equals x squared, f of x equals x squared comes down, that should touch. This -1 shifts it to the right. So the -1 in the parentheses, if you remember, you would have seen this in algebra and pre-calculus. It shifts it to the right. So here we have the vertex, and it's just going to come up like that. And we can put arrows there. So in this section here, we have the 2 minus x. In this middle section, we have f of x equals x. And then in this section over here, we have f of x is x minus 1 squared. So now, where does the limit as x approach a, and this in this case is two-sided, we're not specifying coming from one side or the other. Where does that limit exist? Well, anywhere that the function is continuous, the limit's going to exist. So where are the points where it's not continuous? That's going to be where this function changes in the different pieces. So we have a jump discontinuity there, which we'll talk about at some point. We have a jump discontinuity here. So point jumps, the graph comes up here, but then it jumps down there. So not continuous. So the limit as x approaches a, whatever a is any real number, any number in the domain, which the domain of this is all real numbers, exist when x is not equal to plus or minus 1. And that's all you're looking for. So as long as if as long as the function is continuous, we can consider the limit to exist, the two-sided limit to exist. There's actually one more, if you want to flip that and say when is it continuous, you got to add one more thing that we will talk about at some point. Um, so yeah, so make sure you're good at graphing these piecewise functions. It can definitely help. You don't always have to. I mean, you could figure out uh, you could figure this out without the graph, but graph certainly makes a good visual. So, if you got any questions, you can let me know. If you have any other problems you'd like help with, you can let me know that as well. Have a good day.